Hello students, welcome back to my channel. Today I am going to discuss about the vernier caliper, how to find out the measurement using the vernier caliper. The first thing that comes to your mind that what is the requirement of the vernier caliper, why it is used. A vernier caliper is also called a slide caliper and it is used to measure the length of a rod, the diameter of a sphere, the internal and external diameter of a hollow cylinder. This is the internal. You can find the internal as well as the external diameter of a hollow cylinder. It is also used to measure the depth of a small beaker or a container or anything that is hollow. Now the question arises that how it looks like. So this is the vernier caliper. It looks like. Okay, I am using here the Concise Physics Class 9 book. You can follow the book. So this is how vernier caliper looks like. This is a fixed jaw. There is a fixed jaw. This one is a fixed jaw. It is attached to the main scale. This one is the main scale and this grey portion is the vernier scale. You can see. This is a fixed jaw which is attached to the main scale. It is used to hold an object. You can very well see that here is an object. It is being held by this fixed jaw. This one is a movable jaw and it is attached to the vernier scale. This one is the vernier scale. This one is attached to the vernier scale and hold the object. Okay. There is an external jaw. This external jaw, this is the outside jaw. These two are the outside or the external jaw which is used to measure the external diameter. It is used to measure the external diameter of external diameter or width of an object. And this one is the inside jaw. That is a smaller jaw which is located at the top and is used to measure internal diameter like inside a pipe. It is also used to measure depth. This portion is used to measure the depth. This is a thin rod that comes out from the end of the scale when moved. This is used to measure the depth of the hole of a container. Okay, there is a screw which you can see. It allows smooth sliding and fine adjustment for precise measurement. So these are the parts. These are the different function of various parts of a vernier caliper. Okay, now the question comes that how to find out the least count. How to find out the least count. Okay, so there is a formula of least count, that is the value of one main scale division divided by the total number of division on the vernier scale. I will enlighten you with something like least count is actually the value of one main scale division minus value of vernier scale division. Now let's see how it looks like. This is the main scale. This one is the main scale. This full portion is the main scale portion and this one is the vernier scale portion. You can very well see that 10 vernier scale division. There is 10 vernier scale division. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this 10 vernier scale division, it is coinciding with the 9 main scale division. It is coinciding. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 vernier scale division is equal to 9 main scale division. Okay. From here I can find out 1 vernier scale division is equal to 9 by 10 main scale division. So according to the formula, I have said that least count is value of 1 main scale division minus value of 1 vernier scale division. So value of 1 main scale division minus value of 1 vernier scale division. 1 vernier scale is equal to 9 by 10 main scale division. From here it comes out 0.1 millimeter, or you can, if I convert it into centimeter, it will come out to be 0.0 0.01 centimeter. So this is the least count of a vernier scale, 0.01 centimeter or 0.1 millimeter. So it is clear that 10 vernier scale division is equal to 9 main scale division. Now let's find out how to take the observation. Okay, let's take this portion. The upper one, this upper portion is the main scale reading, and this portion is the vernier scale reading. That is clear to you? So the main scale reading, it comes out to be like this one is 3, 1, 3.1, 3.2, 3.3, 3.3. So 3.3 is the main scale reading. And now how to find out? Plus least count. I have already found out the least count, that is 0.01 centimeter. So least count into the division of the main scale and the vernier scale coinciding. So which division of the vernier scale coincide with the main scale? Like this one is 0, it is not coinciding. 1, 2, 3, 4. You can see very well that this 4 is coinciding with the main scale. This 4 is almost aligned with the main scale and the vernier scale division is in a straight line. So this 4. So 3.3 plus least count into the pth division of the vernier scale. Pth division of the vernier scale coinciding with the main scale is 4. Okay. So 3.3 is the main scale reading plus least count. I have already found out that 0.01 into 4. So 3.3 plus 0.04, which come out to be 3.34 centimeter. This is the reading. Okay, 3.34, 3.34. Now there are in this case there is no zero error. I mean, there are two zero error, that is, one is positive zero error and another one is negative zero error. But when I am finding the measurement, there is no zero error. What do you mean by there is no zero error? How it looks like? See, the main scale and the main scale 0. This one is a main scale 0 and this one is a vernier scale 0. They are coinciding with one another. So no one is ahead of one another. They both are coinciding with one another. So in this case there is no zero error. And no zero error, how can I found out the reading? The one I have done just now, in that way. Now how to find out the positive zero error? This is how positive zero error looks like, in which the one of the main scale reading is ahead of the vernier scale reading. This is the main scale 0, this is the vernier scale 0. The main scale 0 is ahead of the vernier scale 0. In this case I will say it is a positive zero error. So how to eliminate this positive zero error? So this is a positive zero error. Now I will find out to eliminate the positive zero error. The formula is, I'll use the sign plus for positive zero error. Okay. Now I have to find out the division in the vernier scale that is coinciding with the main scale. That is a coinciding division. Over here, which one is a coinciding division? Not 2, 3, 4, 5. This 6. 6 is the coinciding division. So plus 6 into least count. That is plus 6 into 0.01. 0.06 centimeter. Now what will I do? The observed reading that I've already taken, that was 3.34 minus, I will take this reading along with the sign, that is plus 0.06. So 3.34 minus 0.06. Okay, and now we'll find out the value. 3.34 minus 0.06 with 8, 3.28. So 3.28 is the true reading. This is known as the true reading. This is known as the true reading. So 3.28 is the true reading. Okay. Now let's find out how to eliminate the negative zero error. This is how negative zero error looks like, where the Vernier scale division, the Vernier scale 0 is ahead of the main scale 0. Okay, to eliminate the negative zero error, what will I do? I'll use a minus sign and then I'll subtract from 10. Why 10? Because there are 10 Vernier scale division. So 10 minus the pth division, which is coinciding with the main scale, which is 6. Okay, 6 into the least count. So it comes out to be 4 into 0.01, which is minus 0.04 centimeter. I have already taken the reading previously. It was 3.34. I will use minus, I will subtract, and I will use this value along with the sign minus 0.04. 3.38 centimeter. This is the true reading. In this way, I will eliminate the positive zero error and negative zero error. Let me do once again. It will make your doubts clear. This is I've already taken the reading. In this case, there were no zero error. In this case, there is a positive zero error because you can see very well that the main scale 0, it is ahead of the Vernier scale 0. Okay, so I will use the plus sign for positive zero error, and I will see which division of the Vernier scale is coinciding with the main scale. That is a coinciding division, that is 4. It is coinciding. Plus 4 into the least count I have already taken before, 0.01 centimeter. So 0.04 centimeter. Okay, the observed reading was 3.34. okay, minus, I'll take this with the sign, that is plus 0.04, and the true value comes out to be 3.34 minus 0.04, which is 3.30 centimeter. Okay, this is the positive. This is how I will eliminate the positive zero error, and it will give me a correct reading. Otherwise it will be wrong. Your reading will be wrong if you don't eliminate the positive or positive or negative zero error. Now take example of this. It is negative zero error because the Vernier scale is ahead of the main scale reading. And now I will find out which Vernier scale is coinciding with the main scale. Which one is coinciding? This one. These 4 and 5 both are coinciding. But I will take the one which comes initially and the first place. So 4. So I'll minus sign for negative zero error. I'll subtract it from 10 because there are 10 Vernier scale divisions. So 10 minus this 4, okay, into the least count. So minus 0.06 it is coming out, because 6 into 0.01, so 0.06 centimeter. And the observed reading that was there, already I have taken, that was 3.34. so 3.34 minus, then I'll take this value along with the sign 0.06. It comes out to be 3.40 centimeter. So this is how I will eliminate the negative zero error. Thanks for today's class.